evening, everyone. Welcome to today's live class. Today we're covering this topic that we couldn't do yesterday, chemical kinetics. So I hope we are all here, ready for today's class. Hi, welcome everyone to today's live class. Hi, welcome. Hello, are we all here and ready for today's class? Okay, if you're here with me, please drop your favorite emoji. Let me know that we are starting with humans. So today's class is going to be 45 minutes. So by 9 or by 10 minutes after 9, we'll be wrapping up here. So drop your favorite emoji if you're here with me. Drop your favorite emoji. Drop your favorite emoji if you're here with me. Okay. Okay. So I think with that being said, let's just start immediately. We're going to be touching just 10 or 8 major things that I've designed to share today. I don't want us to burn time in today's class because of the fact that tomorrow is Monday. None of us will be. Yeah, Triple A, good evening. Welcome to today's class. Good evening. Welcome to today's class. Good evening. Okay, Joanne, good evening. Good evening. Welcome, everyone. Welcome. Don't forget to subscribe and like and share the link of today's class to a friend. For Saturday, Oyekomi, welcome to today's class. So I think I'm just giving like a minute or two more. Yeah, Isaac Idowu, welcome to today's class. Please share the link of this class to your WhatsApp status. Take a screenshot of this and share it to your friends. Share it to groups that you are. Share it to your WhatsApp status. So I think in a minute or so we'll start the class. I want others to join in. Welcome, welcome. This is what we're doing today, chemical kinetics. And I'm going to be taking you in a different pattern from what you must have been taught. You understand? So it's going to be a beautiful class, trust me. You know, when I say it's going to be a beautiful class, you know that I meant it, right? Yep. Let's get going, boys. Drop your messages, drop your comments. And don't forget to share, because that's the most important thing. We can't feed on this pizza alone. Right? We can't feed on this pizza alone, so we need to share. Yeah. Okay, so with that being said, I think it's 3 minutes already. So in the next 26 seconds or 36 seconds, we'll start the class. We'll start the class, yeah. Are you guys there? Let's keep it coming. Okay. 25 more minutes. We'll kick the start and we start the kick. Please drop your emojis. I want to be sure that people are here. Drop your emojis. Drop your emojis. Sorry? She did night yesterday. Can't buy boss. I'm in class, because yeah, it's alright. Okay, folks, I think, like I said, let's take it fast. I've already drafted out the idea of how this class is going to go, and then we'll defeat it one by one. Let's start. This is it. Today's class is going to cover the first chapter, or the first, what would I call it chapter? The first angle of this topic, chemical kinetics. I hope this is clear. Okay. Okay, now let's go now. So the thing here is this: when you hear the word chemical kinetics, what does it naturally mean? It's just trying to cover this thing called rate of chemical reaction. Rate of what? Chemical reaction. That's what it's trying to cover. And then, so what I want us to do today is I don't want us we should dive into each and every one so deep. No, we don't even have time for that. So what I want us to do today is touch the strong part, the core part of each one. I don't know if you're getting. So I'm going to be teaching you chemical kinetics step by step with tricks. Number one, let's start with what is rate of chemical reaction? Now, rate of chemical reaction is the change in concentration of reaction or products per unit time. Is the what? Is the change in concentration of reactant or products per unit time. That is just what rate of reaction means. Something like this. Now, for example, let's give an example of a reaction now. So something like this now. Imagine when you dissolve when you dissolve salt in water. No, salt in water is not a chemical reaction. It's just a physical reaction. They must have taught you this in SS1. If you are here, anyone that is even here should have been taught, even in SS1. So they must have taught you that when you put salt inside the water, it's a physical change. Now let's just use that for an example in this case. Now, when you put salt inside the water, we have to consider these two things. I'm going to use this book for what is it called? I'm going to be using this book for the sketch and this one for the board. So we consider this. Let's say, no, let's even use something better. Let's use zinc plus hydrogen chloride or hydrochloric acid, whichever one. I think it's good. Should we continue? Okay, zinc plus hydrochloric acid will give us what? Zinc chloride plus H2. Now in this case now, this is the reactant, right? And this is the what? This is the product. This is the product, and this is the reactant. Sorry that I'm using short form. I want to be very time conscious today. Are we following? Yeah. Joy, Ebokafe, good evening. Welcome to today's class. Yeah. So as I was saying now, if you have this kind of reaction now, as the reaction proceeds, what happens is what? This zinc and this acid, they'll be used up. What does the meaning of used up here? They'll be like, I'll break it down into pieces for you. They will get used up. That's the right word I can use. Like, you will not see the zinc again, and you will not see the hydrochloric acid again. What will happen is what? The next thing you'll be seeing is what? You'll be seeing zinc chloride, a salt, and what? Hydrogen gas. Are you following something here? Now, the rate of reaction is the speed at which these two things here will change to these two things. The rate of the reaction is the speed at which this guy and this guy will change to this guy and this guy. That's what we call rate of reaction. So in a simple way, let's say it again. A rate of reaction is what? Is the change in concentration of either a product or if either a reactant or a product per what? Time. That's why the formula is what? Rate of reaction is equal to what? Change in concentration of reactants over change in time. So to say it aloud, I want everybody to write it. Rate measures how fast concentration changes. Let me jot it down for you guys. Now, the thing I want you guys to put in your mind is not PS or nota bene, anyone want to use. Rate measures how fast concentration changes. Sorry, pardon my writing. Rate measure how fast concentration changes. That is just it. I don't know if you get here. Can I continue? Are we there? So that's just the simple ideology behind rate of reaction. So if you want to consider this reaction that I use here now, if you want to use this as a case study now, if you want to measure the rate of this reaction now, what would you do? Number one, you actually what? Take what is it called? We'll take a given mass of calcium of zinc, like a mass of it. Number two, we add hydrochloric acid to it, or we add excess hydrochloric acid to it. Then number three, we notice the change. We notice the change it takes for this zinc to react to this HCl. So we notice the time it takes. So is rate of reaction fastest at the beginning and decrease with time? Yes, but it depends. It depends. Isaac, can you hear me? Isaac, are you there? Is Isaac there? I want to continue, please. Okay. Yeah, the network is bad. Yes, yes, yes. Okay. Thank you. I think I'm back now. Can you all hear me? Can you all hear me? Please, no question today. There is none of you asking who is triple A. Can you all hear me? Okay, let's continue then. So back to your question, like I said earlier, yes, the rate of reaction is really fastest at the beginning and then can decrease over time. It's a general pattern in chemical kinetics. You understand? Okay, let me talk about the step-by-step explanation of why. So write them down. Number one, the reason why I'm skipped to the reason why rate of reaction is fastest at the beginning. Number one, at the beginning, concentration of reactants is at highest. Number one, concentration at the beginning. Concentration at the beginning is at the highest. Concentration at the beginning is at the highest. That's number one. Are you there? So, like for example, now the more the concentration of the reactants, the more they collide, the more the collision between molecules. So that's number one. Number two, should you guys sit in UTME? Number two, as time goes on, the reactant gets used up in the sense that, for example, if you put what is it called? If you carry, you want to fry yam, you want to fry yam, or you want to fry potato. When the oil is very hot, very very hot, and you put the first slice or the first piece or pieces of potato inside the oil, what do you notice? You notice this sound. Now that sound, the reason is because at that point in time, the potato and the oil, they are doing their first initial collision. So as time goes on, what happened? Even when you put new potato, no more again. I think that makes it clear, right? Okay. So number two, as time goes on, the reactant gets used up. So their concentration was number two. The reactants get used up. Reactants. Okay. Well, we can't answer question now. I think let me teach this thing first, so you guys can be answering question later on. So because if I just answer question one by one, I'll end up not teaching anything, and I really have nothing to cover. Isaac. So please let me just answer this one only. So yeah, as time goes on, the reactant got used up. Their reaction decreases, and fewer collision happen, so the rate slows down. So yeah, I think that's just that about that. Let's just go back to what we're doing. So I think I've explained what is it called rate of reaction already. Number two, now let's talk about. Like I said, I want to touch or cover specific things today. Number two, rate laws and order. Rate law and orders. So if you are with your notes and pen, you can actually write that down. Now for a general reaction, this is the formula for it. For a general reaction, this is the formula for it. I hope you get. Now in this case now, we can actually say what? Rate is equals to what? Now let's speak all of this one by one. What is K? What is K? K is the rate constant. Is the what? The rate constant. Are you following something here? Then what is A? A reactant. Same thing with B. And then what is M? This M here. Let me use blue for that one. M is order with respect to A. Hey, Jesus. M is order with respect to what? To A. Then N is the same thing as what M is to B. I don't know if you get this formula. Please, I want you to follow this formula that I'm actually dropping down and understand them perfectly well. But we'll use them to solve questions towards the end of the class. We have 30 more minutes. Like I said, the class one is just 45 minutes. So write this down. This is the formula to get what is it called? Rate law. After this, a general reaction like this, A plus B to product, the rate will be equals to what? constants, A, and then M, and then B, and then N. In this case, the exponent tells us the sensitivity, and these are the exponents. Are we there? Shukurat, people have started, Abi. You have started asking questions on the text instead of to focus on the class. Can I leave this place? Can I leave this place? Can I leave? Okay, now, see, let me just pause here now, and let's ask our first question for today. Now, our first question for today will be this. Question 1. Sorry. Question 1. When 0.6 gram of cacotri, that's calcium tricarbonate, was, can you say it here, added to excess dilute HCl. If you are following me, oh sir, can you hear me now? How is it now? Can you hear me? Can you hear me? Let's continue then. So, when 0.6 gram of cacotri was added to excess dilute HCl, CO2 was evolved. CO2 was evolved. The entire reaction took 5 minutes. What was the rate of reaction? So, before you solve this, I want to ask a question. Before you solve this, how many of you can solve it? If you can solve it, type yes. If you cannot, type no. My question on the board or on the book now, if you can solve it, type yes. If you cannot, type no. How many of you can solve it? Okay, I've seen Atonda, I've seen Joseph, I've seen Joanne, I've seen Usman. In that case, let's solve it then. No time wasting. Let's solve it if you cannot. So first of all, what you will do is this. The first step, let's bring it out. You know, what's the formula for rate of reaction? I think I mentioned earlier. Formula for rate of reaction is what? Mass of, it is change in concentration of reactants or change in concentration of products over what? Time taken, right? Do you remember? Let me say it again. Change in concentration, this is it. See the formula for rate of chemical reaction. So it is change in concentration of a product or change in concentration of reactants over change in time. Now, in that scenario now, in this case, they asked us when 0.6 gram of cacotri was added to excess dilute HCl, CO2 was evolved. The entire reaction took 5 minutes. What was the rate of reaction? In this case, we don't really have concentration. We only have mass of the reactants. So that mass of reactants will apply to be our, to be our, our formula used. So in this case, the formula to use here is rate of reaction is equal to what? Amount of reactant Amount of what? Reactant. Please write down, write down amount of reactant over time taken. Do you get? Now that amount of reactants now can be should be in what is it called, mole per dm cube. So time taken is about what? Seconds. Do you understand this part? But in this case, we also don't have amount of reactants in mole per dm cube. We only have it in mass. We have it in I'm going to cancel it though. We have it in mass 0.6 gram. So what we'll do is this. The formula, the parameters we're using is here is what? 0.6 over time taken. What was the time taken? 5 minutes. Do you understand? So is that we convert the time taken to seconds or we leave it in minutes? Though in most cases, for what is it called? For rate of reaction, time taken is always in minutes. So let's leave it in minutes. Now that's 0.6 over what? Over 5. Now solve it. What do you get? Okay, 300 seconds. What if you are using minutes? What will be the answer? Is sac, you know. So 0.6 over 5 is what, guys? Type. Oh yeah, 0.6 over 5 is what? Okay, yeah, correct. No. It's not 0.12 minutes though. It is 0.12, correct, but it's not 0.12 minutes. You guys have messed it up, but it's not 0.12. Oh. Somebody write 0.12 minutes. Okay, I don't know this person's name, Jesus. Atondabalikis. It's just 0.12. Now let me explain what it means. It's not 0.12 minutes, it's just 0.12. Is 0.12. See, because I say when 0.6 gram of calculated was added to excess dilute CO2, HCl, what CO2 was involved. The entire reaction took 5 minutes. 1 of reaction. So the rate of reaction is 0.12, not 0.12 minutes. Hey, are these people, are they getting it? That's why I like you guys to respond, because when you respond, it's easy for me to follow what you are missing. Are you there? Do you understand now? How do you get 0.002? How? Uh, how do you get 0.002? Joy. Please confirm or confirm. How do you get 0.002? We have 20 more minutes. Okay. Okay, let the answers keep coming. A moment, please. A moment, everyone. Oh, you change the time to seconds. Okay. But wait. If you change the time to seconds, will it be 0.000? I don't get. What do you even get earlier? Let me check your answer again. That doesn't really mean now if you even change it. Okay, I think so. I've got the answer. Let us move ahead before time catches up with us. So the next thing we're doing here is this. Like we said earlier, is since we have done rate law, right? We have done rate law and orders. Okay, so the next thing we're doing is this. Which is my mic on? Is my mic on? Okay, we'll be doing how to. Okay, it's all right. How to find orders. Now, okay, let's move from here. We're doing. Don't forget this formula, please. Don't forget this formula. Don't forget this formula. Now we're going to how to find order now. Number 3. How to find orders. Now, so the first one under this case is this. Let's start with I, initial rates method. I'll teach you the quickest method on how to find these things if you have been taught already. And if you're not taught yet, you will also know it through the way I want to explain it. Initial rates method. Now, in this case now, we'll compare 2 experiments where only one concentration changes. Do you understand? If you are comparing 2 experiments where only one concentration changes, 2 experiments, what you do is use rate 2 over what? Rate 1 equals to please write this down. Please write this down. Should we continue? Should I continue? Now, then, if you have to solve for this, what you will do is this now. M will be equals to, let me move here. M will be equals to log A2 divided by A1. Now the first trick here is this. The first trick here is this. If you are doubling, A, so if doubling A doubles the rate, then order in A is equals to 1. Oh, is it clear now? Please, who again is not seeing it? Joseph, is it clear now? Okay. Please jot this one down. Am I making this class too advanced, or should I just slow it down and go back to the beginning and explain collision theory to all of you? I believe this class is supposed to be like a continuation class. Should I start from the scratch or this is okay? Please, if this is okay, just say yes, and if it's not, we have just 13 more minutes before this class is over. But if you think I should start from the conclusion theory, explaining every baby thing, how the action varies, let me know. But I believe this should be what is it called? Oh, Usman said yes. Usman, I don't understand. Should we continue like this, or should we start from the simplest basics? That's my question. Okay, let's continue. It's all right then. So I think that is just the first trick here. So if doubling A doubles the rate, other is equals to what? Other in A is equals to what? 1. So I hope we understand that aspect. Now in the next what is it called? Let's try to do my fourth target for today. Now, or should we do this way? Let's treat a work example now. There is no time. I have 12 more minutes. Okay, no, there's no need. Don't work example. I'm going to do that one in the next live class. So I'm going to teach you two methods, and like I said, how to find order. You can use the initial rate method when you are comparing two experiments. Rate 2 over rate 1, then you get amounts of this, and then you go with this. Do you understand? Remember I gave you the parameters here, right? M is just the order with respect to A, and then N is order of respect to what? To B. So I'm looking for M in with respect to order of what is it called? To A now, in this case. So if you're looking for such, how to find orders using the initial rate method is rate 2 over rate 1, then A2 over A1. Then you bring out your M, which is the order now, and you become what? Log rate 2 over rate 1, log A2, A1. Do you understand? So the first trick now, like I said again, don't keep it in your mind for OBJ question. If doubling A doubles rate, order in A is equals to what? 1. It's as simple as that. There's no selenium in it. So the second method I was talking about here. Are we there? Are we following? Second method I was talking about here is what I call the short algebra method. And the short algebra method now, that's when you have many variables or when many variables changes. So in this case now, use a log formula above. I don't know. Do I need to really explain this one? I think most of us should be familiar with it. I want us to finish this thing before this time wraps up. I want us to finish at least 5 targets of mine. I've did the first one. I've defined the rate of reaction. What is it called? I've given you this, how to get rate law and orders. And I've come to this, how to find orders. So I really want us to finish at least 5 out of the 10 I kept for you guys. So number 4 is integrated rate laws. Integrated rate laws. Which first one? Which first one? Some people said no. What others are saying no? Please, what do you mean by your no? I want to carry everybody along. At the same time, I want us to be very fast. Today's class is not 2 hours or 1 hour. Just 5 minutes. So please, anything you want to say, specify very well. You don't understand B, C, or whatever your name is. You're just joining us now. You're not here from the beginning. Okay, I should continue. It's all right then. So, integrated rate laws. In this case, what to plot and quick test. Now, this will let you find K from concentration versus time. See, let's come back to this thing. You see this thing here? K is rate constant. A amount of moles. M with respect to A. B is there, then N respect to B. Do you get something here? Now, in this scenario now, we have now to find M. I'm finding N also, the same thing applies. Now, how to find K? In this case, that's where integrated rate laws comes in. How to find K from concentration versus time. So in that scenario, jot these points down. Zero order. In zero order, A is equals to Jesus, I made a mistake. A bracket 0 minus KT. I hope you get. And now what do? You plot your, what is it called? A against T. And in this case, it must be a what? A straight line with slope. I feel some people are lost. Is this under the short algebra method? No. This is not under the short algebra method though. The short algebra method is what I already gave above. I gave it above already. This one I'm talking about now is integrated rate laws. When you are looking for K in respect to concentration versus time. Is it clear now? Let me say this again. This is not like a fresh life pass from the start. It's like a continuation. I'm just hitting the major parts that will make you understand this thing. I hope we get. Do you understand this? Okay, good. So please, if you don't understand, feel free to ask your question, to drop your question. I'm going to say it again. This is not like the electrolysis class or the organic chemistry class that we're doing that we start from the scratch. This one is more of just me touching the main part. And we have 6 more minutes. So if you have a question, kindly drop it. Do you get? Now, this was zero order. The next one, if you are dealing with first order, what you do is this. In this case, the A is equals to A, then constant C. How do you plot it? You plot versus, which is what? Also straight line with slope. That's it. We are in 40 minutes already, which means we have to move on to answer some questions. I think I'll stop here. Or should I give you second order, which is for one reactant? Let me give for second order before we close for the day. For second, are we done with this? Sorry, are we done with this? Hello, if you know, sir, what about SS2? I'm not starting this topic. Okay, sorry. Jesus. Oh, okay, I'm confused now. It's supposed to be a continuation. Probably I will create some short videos that will explain this thing from the scratch. I'll make you understand all this I'm saying, all this I'm doing. Who is saying no? Okay, so just drop this down. Drop this down in your notes before we take some questions. Yeah, Adele, okay, please, this class is, I don't know, I'll make it too hard, right? Jesus. Sorry. This is more of just a summarized aspect and how to get it very fast. Okay. Okay, yeah, I think I believe you. If you have not done it before, you can't actually get it. You're not done before you can't really get it, so I believe you. I think let's stop here for today. Don't let me make it too complex again. So I just want us to just treat some questions and then we close. And our live classes are moved to Wednesdays, Friday, Saturday, and Sunday. We have now, this is it now. We have Maizikido. Oh, I don't understand what you're trying to say. Yes, it is for SS2, but at the same time, it is, how will I say, it is a continuation class. I did not start from the scratch. Do you understand? I did not start from the scratch. I don't know your name. What's your name? The guy with herbsc.ng. I don't start from the scratch. Okay, the live classes are Wednesdays, Fridays. Fridays are not sure. Wednesdays, Saturdays, and Sunday on YouTube, or if it will be TikTok to be announced. So let's solve this few questions before we go. Please, Isaac, you will leave facts here alone. I did not ask you to do A. Let's solve this question before we go. I think we have Jesus. It's only 45 minutes. Now, question time. Question time. I might not be able to write them because of timing. So number one, the concentration of A, the concentration of A decreases from 0.200 mole per dm cube to 0.150 mole per dm cube in 40 seconds. In 40 seconds. Calculate the average rate of reaction. Now solve that for me, please. Calculate the average rate of reaction. Solve this for me. Solve it ASAP. Can you please treat this topic in your next live, if possible, and what time do you usually start? Okay. Oh, is it clear now, Fatia? Okay, can I treat this topic next? Oh, are you trying to ask me that? Can I start from the scratch? Is that what you're trying to ask me? Let me get this straight. Because I'm actually treating it now. The only difference is just that I did not start from the scratch. That's just the difference. So, it's more, this class is like specifically for my students. Okay, from the scratch. Okay, the thing here is this. Please keep on solving. Oh, don't wait for. I'm talking to the guy, but if you're not with me, keep on solving. Keep on solving, please. I'm trying to write the second question down. Okay, Abdulamin, I just joined the class. Welcome. You try. You come very early. Abi, Fetia, he came very early now. He's here very early. We're about to close the class already. Is it clear, Jesus? Okay, it's clear. Who is done with the question? Anybody done with the question? It's only 45 minutes, so let's close, please. Tomorrow is Monday, and we all have to rest. Yeah, I'm not doubting you. I'm not doubting. Number one, don't forget you come very late. Allah everybody is just coming. What is it there? No wahala. A cabo. Okay, if you can hear me, everyone, please don't forget to follow our account on Facebook. So I say Facebook on TikTok. It is also Nelson Learning Space, and sooner or later we'll be going there. We'll be going live on TikTok. So just go there. I want you guys to bombard our TikTok account. Push it to at least 150 or 200. It's currently almost at 100. I use change in concentration. Drop your answer, Usman. I can't solve it at all. Voila. They won't happen to do like this. It's very simple now. Uh-huh. Okay, should I solve it for you guys? So this guy gets, yeah, Isaac. Oh, sorry, Isaac. It seems we are close. Okay, you know what? Let me just solve this question so we can close for the day, guys. Let me solve this question. For those that want me to start from the scratch, that's not a problem. We will schedule a class for that. But this week, the topics in our hands are not chemical kinetics. So I'll think of a day we can actually do it. Probably that might just be a bonus class. I'll just think of any of my free days and do it. So let me solve this question. So how do you solve this kind of question? Is it rate is equals to, let's look at what we have here. The concentration of A decreases from 0.200 to 0.150 in 40 seconds. Calculate the average rate of reaction. Average rate is just change in concentration. So let's use A as concentration here, over change in time. And when you're dealing with change, what does it mean? You always use, is always equals to final minus initial, then time also. And they don't really give us two different times, so it's still over 40. So here, what's the final? It's from year to year. Right? From here to here. I hope you get it. So this will be the final. This will be the initial. In this case, that will be equals to 0.150 minus 0.200 over 40. And what do you get with that? That will be equals to 0.150 minus 0.200 is what? That will be... Yes, we have solved it. I know. You are correct. You are correct. Oh, Usman, I did not see your answer. Oh. For all of you have solved it. Correct. The answer will now be 0.050 over 40. Then when you divide this, what you get is 0.00125. Hey, let me bring this out so I can bring out the units for you guys. That will be equals to 0.00125 mole per dm cube per second. So that's the final answer. So guys, all of you that come very late, that's you guys' problem. We are closing already. You have spent extra 6 minutes in this class. So guys, good night everyone. If you know you did not understand what I did today, because of how I designed it, I will take another class on that chemical kinetics where we start from the bottom scratch. So please do well to share our accounts and do well to follow us both on Facebook and subscribe, both on YouTube. Follow us on TikTok and subscribe to our YouTube channel. Bye. It's not negative, oh. Is it negative? Wait, am I missing the question? Okay, it's supposed to be negative. Yeah, it's negative. Is it negative? It's not negative now. It's not negative. So please, good night. Yeah, Abdul Mumin. Thank you for coming late. Good night. Ó dàbọ̀ o.